to start the recording. I laid the foundation in the last class about routing in general, or the routing concept. And don't forget, we talked about we have dynamic routing protocol, and we also have static routing protocol. So today we're going to be talking about static routing protocols, and we're also going to do the configurations of the static routing protocols.
So video, sir.
I have started, ma.
I can't see it, sir.
You mean the recording?
No, the screen, your screen, sir.
Oh, you can see my screen?
Yes, sir.
Who else is not seeing the screen? Dr. Samuel, can you see my screen?
I can see it. I can see it.
Okay, Mr. Adedmink, are you using a phone or laptop?
I'm using phone, sir.
Maybe you should log out and maybe you should log out and log in again.
Okay, sir.
Is that right? Okay. So we're going to learn about static route. We've discussed it briefly, but we're going to talk about static route. Please mute yourself. As you come in, mute yourself. So we're going to configure static routes, and I'm going to be doing only based on IP version 4. You are going to practice the one of IP version 6 in the lab because it's the same concept. It's just the change of IP address. So this is the first one we're going to do. We're going to do static routes. Then we're going to do default static routes. We're going to also do floating static routes. And then we're going to configure static host route. So it's a long journey today. Long journey. But once you know how to configure one, the rest are just very simple. You just need to know when to configure which one. So anytime you talk about static routes is, you have different types of static route. It could be just a regular static route. Sometimes we call it standard static route. Or it could be default static route, or floating static routes, or static host route. And you need to know all of these static routes. Why do I need them? So the first one is static routes. So look at them here. Types of static routes. Static routes are commonly implemented on a network. This is true even when there is a dynamic routing protocol configured. Don't forget I said when we start our TCNA3 class, that's when we'll be learning the dynamic routing protocol, and we're going to do only one. Static routes can be configured for IPv4 and IPv6. Static routes can be configured for IPv4, IPv6. Both protocols support the following types of static routes. So the first one, look at them again. Standard static route. We're going to do that first. Then the second one is default static route. We're also going to do that. The third one is floating static route. We're going to do that. Here they now mention summary static route. Summary static route is different from host routes, but I'm not going to do summary static route for you guys. I will do the host routes. I don't know why they're still talking about summary static routes. We hardly use summary static route. I'll probably just explain the concept for you, and I will leave it there. So this static route that I'm talking about, what is it all about, and how do we configure the static route? Don't forget, this is a manual configuration we want to do. What do I mean by manual? Okay, I have a plain sheet here. Good. What do I mean by manual? Let me give you a scenario. I spoke about this on Wednesday, so I'm going to do it again now. I have a local area network. This is my switch. There are computers connected here. Let's say this local area network is in London. Then I have another local area network. Let's say this is in Germany. These are computers connected. And for some reason, we want to link the two local area networks together. Maybe they belong to the same organization. So how do we link them up together? We need a router in London to be connected to the switch. We've been doing similar stuff, but not for this kind of design. We'll also need a router in Germany to be connected to the switch. And then we need to connect the router in London to the one in Germany. And what is going to be here? This is what we call wide area network. It can be achieved through different technologies, different ways to get it all done. Because I know in your mind, you'll be like, how are we going to connect our router all the way from London to Germany? In networking, there is no distance. It's like in the spirit realm, there is no distance in the spirit. The same thing in networking. We can achieve anything in networking. We can connect anything to anything in networking. So just trust me, that connection is there. So this is going to be the challenge. Let's assign addresses, subnet or IP address, network addresses to all this LAN. Let's say this LAN in London is on 192.168.100.0/24. The LAN in Germany is on 192.168.101.0/24. This is a network here, we know that. This is another network here, we know that. In between two routers is a network. Don't ever forget that. In between two routers is a network. Don't ever forget that. In between two routers is a network. So what does that imply? It means I need a network address also for this link. So I can say this is 192.168.102.0/24. Normally, our one link is always /30. And from our knowledge of subnetting, you know what that means. We have two usable IP addresses. One is going to be on this interface. One is going to be on the other interface. But in order not to confuse people, I'll just speak /24. So this is going to be our design. A local area network in London. Want to talk to a local area network in Germany. How is this going to work? How are we going to make this happen? The router, based on what we discussed in the last class, we only know about the directly connected network. It will know about this one, and it will know about this network. So London router knows about 192.168.100.0 in its routing table. London router will know about 192.168.102.0 in its routing table. Those are the only two networks that we can reach, that the London router can help us to reach. But now, if somebody here, let's say this is me, this is Roland. I want to talk to Dr. Samuel. Dr. Samuel is in London. I need to pass through the router to go to that Germany rather. I'm in London, he's in Germany. I need to pass through this router to go to Germany. So the London router or the router in London that I'm connected to, does he know about the network in Germany in his routing table? Don't forget what I said about routing table. It's like your GPX. If the London router does not know about this network, there is no how I can get to Dr. Samuel in Germany. So we need to find a way to tell London router about that remote network. This is called a remote network. A remote network is a network that is not directly connected to that router. So we have to find a way to go to London router and say, there is a remote network somewhere. In case you want to talk to that network, this is how we can get there. Is Ali in the class? He's asking if we have a class today. Ali, are you there? I don't know. So, okay. No, it's not the one. So we need to find a way to tell London router about this network that is remote. But guess what? Even if we inform London router about this remote network in Germany, Germany also has a network it does not know how to reach, because this network that Roland is connected to, the Germany router doesn't know about this network. So we also need to tell Germany router about this network. If not, I will go to Germany to talk to Samuel. Samuel will want to reply back, but will not be able to reply back. Why? Because the Germany router doesn't know how to get to me. So that is the background of what we are trying to do right now. We want to be able to tell the router manually about remote networks. And we are going to be using static routes. That is the standard static routes now. We're going to be using the static route, meaning we are going to tell these routers manually about networks that are not directly connected. Let's do it before we come to the story again. So let me bring back one of the networks we have worked with before. I don't know if it's in this class or another class that I've taught. So we've worked, I believe we did something like this in one of the, when we started basic router configuration, where we had two LANs, LAN A, LAN B, and stuff like that one. Now this shouldn't be your home. Let me look for your home. I can't remember which one is the one for this class, but I can use anyone anyway. It's almost the same thing. Let's just use this. Now, if we take a look at this network now, or this topology we have here right now, there are two LANs here. But those LAN are within, the two LANs are within the same area, same location. We just decided to segment our network. So this is one LAN here. This is another local area network here. And based on our configuration, we use our router to link the two local area networks together so that people in this place can talk to people in this place. We did that already. And this is not VLAN, this is real LAN. If I go to the router right now and check the routing table of this router, you're going to see that the only two networks that this router can talk to are the networks that is directly connected to show IP route. Don't ever forget that command. Or let me say show IP route connected. I want to see the directly connected network. You can see that this router is directly connected to 192.168.100.0/24. See, it is directly connected on this interface. Then there's another network, 192.168.101.0 is directly connected on gigabit 0/. Those are the only two networks that this router knows about. And those are the only two networks that can talk to themselves through this router. But I want to bring in another router. Let's now assume that this, my router, is in London. Then I want to have another router, say it's in Germany. Say it's in Germany. So let's build a LAN in Germany, just one LAN with one router. Let's have a LAN in Germany. I have just one computer, just one router. And let's have a network address. So we can pick, this is, I can pick 192.168.102.0/24 for Germany's network, the local area network in Germany. This will be the network address. So let's link them up. So I'm going to build that LAN independently of the other one. So I'll just go to this router, just put basic, just put an IP address. So let's name this router Germany. Is it 200 or 192? I think it's 192, sorry. One nine two dot 168.102. I want to use the first IP address. And then activate the interface. No short. So I'm done with this router and save my configuration. So now I'll go to this computer, give this computer an IP address from that network, 192.168.102. We can give the computer say .2. We're not going to give switch IP address. I'm not using the switch for anything. I'm not managing it. Then tell the computer about its gateway. Then now make sure you can reach that gateway. Don't forget, you build, you verify. So now, this computer in Germany can hit its gateway. You can talk to its gateway. So, okay, good. So now, what if we want people in London, in LAN A, in LAN B, to be able to talk to the LAN in Germany? And we want the LAN in Germany to be able to talk to the LANs in London. First and foremost, we know that we need to link the two routers together because they are separate now. The router is doing its job in Germany separately. The router is doing its job in London separately. All the things we've been learning all this while about router configuration, VLAN, whatever, DHCP, these are just for separate LANs. But now we want to link the two LANs together. And when I talk about two LANs, this concept is applicable to as many LAN as possible. You can use it for 50 LANs, for 100 LANs, and it doesn't matter the size of the network, even though we have said do not use static route for a big network. But it's the same concept. So what I need to do is to link the two routers together. And router to router, I am going to use crossover cable. In the real world, back in those days, we use serial connection. Take note of my last statement. We use serial connection. That is why when you see us connecting two routers together, we always put this sign. This sign is serial connection. Why do we use serial connection back in those days? Most of the wide area network technology they use in those days, they work with serial ports. Serial port is a port on the router. I don't think I've ever showed you guys. We know Ethernet, gigabit, and all of that one. But what we are doing in the lab, we use crossover cable just to simulate this one connection. Because I don't want to use serial. People don't use serial port again because most of the technology that goes with serial connections have gone. They are dead. Nowadays, people use Ethernet connection, gigabit, and so on and so forth. So this is just our imaginary wide area network connection. So now I have linked the two routers together. I have linked London to Germany. Any technology can come in between. After today's class, I'm going to send two videos, one on wide area network, one on VPN. These are some of the technologies that can be used, even though CCNA didn't go in depth. And you need to know this. Let me explain this to you. In the cloud here, or let me say, don't let me use the word cloud. Inside this wide area network, most of the time, the people that help us to get this job done are the telecos. Telecommunication companies. They can give us, they have what it takes to link us up, like cable modem, DSL, and so on and so forth. Most of the time, they are the one that can give us this connection. So as long as they have what is called point of presence, we're going to discuss that in the next class. They can give us that kind of connection. So just trust me now that we can link the two routers together, regardless of where they are located in the world. Now I said between two routers is a network. So I must connect these two routers together and they must be able to ping themselves. Before we even talk about LAN connection, these two routers must be able to ping themselves. It therefore means we need to now give another address to the one connection. So let's say we want to use 192 168.103.0/30. Why am I using /30? If you go back to your subnetting, /30 will give you two usable IP addresses, only two. Only two. .1 and .2. The network address is .0. Broadcast address will be 3. So go back to your subnetting. So I can put .1 on one side of the link, put .2 on the other side of the link. So let me go to this side and put .1 on that side. Interface G0/1, IP address 192.168.103.1, 255.255.255.252. When you do your subnetting and calculate the new subnet mask, that's what you get. I am done on Germany side. Then I'll go to London side. The interface we are using there is 2, G0/2. I'll enter the interface G0/2, IP address 192.168.103.2. Subnet mask 255.255.255.252. No short. So these two routers must be able to talk to themselves over the wide area connection link. So now let's see if they can talk to themselves. Don't forget what I taught you. Build, verify, build, verify, build, verify. So now ping the other side. I'm in Germany. I want to ping the London router. I'll say ping 192.168.103. London router is .2. I want to be sure they can see themselves. Beautiful. You can see now the two routers can communicate. So now I am done with this connection. I'm done with this connection. So from here now, don't forget, in between two routers is a network. And this is their network address. We put .1 here, we put .2 here. And we make sure that the two routers can see themselves. What are we trying to achieve? We want the local area network in Germany to be able to talk to this local area network in London and also talk to the second local area network and vice versa. We want them to be able to talk. But right now, can they talk to themselves? No. Why? We're going to confirm that. Now, take note of something here now. In this topology that I have 4 networks. 4 networks. This is the first network, my second network, my third network, and this is my 4th network. All the routers in my network must have 4 different networks. Some are directly connected, some are manually configured. All of them must have those 4 networks before there can be exchange of information. But with what we know on the router, a router will only record in its routing table the directly connected networks. Like this router in London now, it will have this network in its routing table because that interface is connected directly. It will have this interfaces in its routing table. The interface that belongs to that network is directly connected. It will also have this interface in its routing table because the network is directly connected. We're going to see that. But what happens to this network here that is not directly connected? This London router does not know anything about this network here. And if it doesn't know about this network here, it can't help anybody from here to go to that network. Even if you go and inform London router about this network that is here, so that somebody here can go to this place, when the return is coming back, the Germany router, if he doesn't know about the network that is replying back to, there will also be a problem. So the Germany router is not directly connected to this network. It's not directly connected to this network. So we have to go to Germany router and inform Germany about this network, So there must be synchronization on all my routers about the remote networks. Directly connected, they will learn it by default. So let's confirm that on the London router. So I'll say show IP route connected. I want to see directly connected network. You can see all the networks that are directly connected. They are in the routing table of my router 1. Let's name this guy London. They are in London router. So now, because they are directly connected, those are the only networks that this London router can reach. Let me remove the connector so you can see all the networks that the router knows about. Look at them here. There's the directly connected. We've talked about the local host. That's the one that is configured on the interface. This is another directly connected. This is another directly connected. Now you realize that the network under Germany, which is 102.0, is not available in this routing table. And as long as that network is not available in this routing table, nobody under London will be able to reach that network in Germany. Nobody. Let's try before we fix the problem. Let's try. The computer in Germany, I gave it .2, 1 and 2. So let's try to ping it. Ping 192.168.102.2. That's a computer in Germany. See what it's telling us here. Destination host unreachable. Well, I don't even have an idea of how to get to that destination. No idea. Why? The router has no idea. And there's this reply coming from who? It's coming from the router. I don't have an idea how to get to that destination because it's not in the routing table of this router. So we can now go to this router and tell London router manually about that network that is remote under Germany. When I say remote, it means it is not directly connected. How do we do that? I'll go to London router and go to global configuration mode and say IP route. I'm simply saying London router. You know what? There is a network somewhere. You don't know about it. It's not directly connected to you. But I want to inform you. I want to tell you about the network. IP route. That's the command. 192.168.102.0. That is the network address. The subnet mask 255.255.255.0. So I'm simply trying to tell my London router that there is a network somewhere. This is a network address. This is a subnet mask. And in case you have message for anybody on that network, send it to 192.168.103.1. Who is that? The next router. That is the IP address. Thank you. Somebody's already feeling me. Then you give me thumbs up. This is the IP address that we put on this interface. So we are telling London router, if you have any message for this guy here, if somebody is trying to go to that direction with this subnet mask, just send it to the Germany router. Germany router knows how to get there. That is what we are telling this router now. So the IP address we put on this interface is 192.168.103.1. We'll say, if you get any message, it's not your business, it's not your headache, just send it to this router. This router will sort it out. So by the time we are done with that, what do? We'll hit enter and we are done. We have informed our router about 192.168.102.0 with this subnet mask, send it to this. If I go back now and say show IP route, you'll see that my route has been entered into the routing table. Which route is entered into the routing table? 192.168.102.0/24. What do you have in that bracket? Administrative distance of static route, and the metric is 0 via through 192.168.103.1. And the S simply means what? We did it. We did this statically, manually. We informed this router manually about that remote network. Okay, now that this router has that in its routing table, can we ping that destination? Let's try again. Let's try again, because now where we're trying to go to, We've informed the router about the whole network, so we can ping anybody on that network. So can we ping this person on that network? I like networking. And when you know what you are doing, it's sweet. You see that the message we are getting right now is different from what we got before. Before, we got destination host unreachable. Anytime you get that kind of message on your network, you know that there is serious problem. Serious problem. Once you see destination host unreachable, it's serious problem. But once you are seeing request timeout is a bit better. So what is happening? This router is still not going, it cannot help us to get to that destination, even though it knows about that destination. Now, the reason why you are seeing request timeout now is because the router knows that I can get to the destination, but for some reason, I can't really reach the person, or I can't get a reply back. Why can't we get a reply back? Let me show you. This computer we're pinging from belongs to which network? ipconfig. This guy belongs to 192.168.100.0 network. We are going to Germany to ping somebody under Germany. Watch out. We want to ping somebody from here. We want to go to Germany to ping somebody here. The message we get to this place. When the message you reply is coming back, this Germany router doesn't know about this network in its routing table also. So he can't bring a reply for us. We cannot get a reply because Germany router does not know where he's going to drop the message. So what do? We go to Germany router and say, Germany router, let's check your routing table. What do you have in your routing table? You have two networks you are directly connected to. One is 102.0. The other one is 103.0. But there is a network you are trying to send a reply to. It is 100.0. It is not in your routing table, so you can't send the reply there. When you say, okay, no problem, let's fix that problem. IP route 192.168.100.0. That is the network where we are pinging from under London. Then the subnet mask 255.255.255.0. That is the subnet mask. And where are we going to pass through? We're going to pass through London router together, which is 192.168.103.2. So what have I done? I'm just telling Germany router there is a network remote to you. It's somewhere on this organization. This is the network address. This is the subnet mask. If anybody wants to go to that network, just send the message to this particular router with this IP address. It is called NestHub. Then if we check the routing table of this router now, we will see now that that network is now in the routing table. Volume is faint. Dr. Samuel, can you hear me? Somebody said volume is faint. Okay, at least they said it's fine. Maybe it's from your hand. So now we have that network in the routing table of our router. Thank you, doctor. In the routing table of our router. So Germany router can send a reply back. Let's find out. If it doesn't work, we do troubleshooting. Why will it not work? Maybe we made mistakes somewhere. That is the beauty of network. Why is it not working? So let's do troubleshooting. Why is it not working? Did we do our configuration well? Find out. So now I'm going to troubleshooting now. It's good to make mistakes sometimes when I'm doing this because it will force me to teach you how to troubleshoot. So what do you want to find out first? Depends on how you want to start your troubleshooting. I can start from gateway issue. This computer here, does it have gateway address? Can it reach its own gateway? That is the one in Germany. So I can find out, can you hit your gateway? I think we did that before. This guy can hit his gateway. Gateway is 102.1. It's okay. Then the other guy that is trying to ping out to, can he hit his own gateway too? What's his gateway address? Because if you can't hit your gateway, then you can't go out. This guy is, the gateway is 192.168.100.1. This guy can also hit his gateway. Okay, so what's the matter here? I don't know yet. Let's find out. We did configuration to go to the other network from Germany. Then we did from London to Germany. So let's check what we have in our routing table. Let's go to London. London, the static route that I have here is 102.0. Is it the correct configured network? 192.168.102.0 is correct. Did we point it to the correct next hop? We say 192.168.103.1. Is that the next hop? Let's confirm. Show IP interface brief. This interface is .2. The other side should be .3. Then is that interface reachable? 192.168.103.1. The interface is reachable. Let's go to the other side. The static route we configured there. Did we configure it well? Let's find out. Okay. We are pointing to 192.168.0/24. Yes. We pointed it to 103.2. That should be correct. Show IP interface brief. Ping 192.168.103.2. That's the other guy on the other side. It's reachable. So where is the problem? Where is the problem? Troubleshooting time. So let me see if this router can hit that IP address. Ping. Let's just check this guy's IP address. This guy is 100.2. So let me see if this router can hit that IP address. Ah, I can't you get there? Oh no, I think ping 192.168.100.2. Wow, my router can hit that .2. So why can't this guy ping? Let's ping from here and see. Doesn't make sense. Okay, guys, let me restart this router. From my experience, I've had one issue like that. I taught a class DHCP. I did everything. The thing refused to work until I shut down that class. I said I'll get back to them. Then when I got tired of going through it, I just decided to restart the router and then it worked. So let's restart the router and see. Because the configuration is okay. We should be good. Okay, let me do something. Yeah, that shouldn't be a challenge. That is slash 24. The other is slash 24. This is slash 24. Okay, let me go to the other side and see again. So what we are doing right now is called troubleshooting. Verifying that we have the correct configuration both ways. So let me see if this computer can ping .2 now. Okay, so let's do something. Let's get rid of our static route and put it back again. If that doesn't work, I will save this and sit down with it later and set up another one completely. Just two lamps. Let me remove the static route that I've configured here. I can copy it from the output of show run and get rid of it. How do you get rid of it? The way we put it is the way we remove it. Know that you put everything. Remove my static route. Show IP route. The static route is gone. So let's go to the other side also. No. Then you put this. Then static route is gone. So let me save and reload again. So sometimes when you run into trouble, work your way back, save your job, reload your router. Work your way back, save your job. When I say work your way back, undo what you have done, restart the router, and then you do it again. And most of the time in the real world, this works. And the reason why we have issues sometimes is not because you did the wrong thing. Sometimes you have what we call bug. If the router has the bug or the switch has a bug, you sometimes do some configuration, they don't work until you probably update the operating system. But I don't want to say that's the problem now. So let's go back to this our London router and see the LANs we use it to connect together before. Let me be sure that they can even talk to themselves. This is 101.2. So let me ping from this place to 101.2. Ah, fair for catch me. Okay, they can ping themselves. It's okay. So now I want to travel back to the other side. So I want to do this configuration again. So this side we want to reach is 192.168.102.0/24 on London router. So let's do the configuration again. IP route 192.168.102.0 subnet mask. Then the exit 192.168.103.1. That is the next router. That's the IP address of Germany router. We hit enter. We go to the other router and do vice versa. Ideally, we're supposed to do for the two networks on this side. IP route 192.168.100.0 255.255.255.0 192.168.103.2 Let me check the IP address on the show. Okay, the other side is .2. So I am configuring to be able to reach 100.0. But mind you, we also have another network, which is 101.0. We can configure for the two networks so that we can reach the two networks from Germany. Let me do for the second one too. So 101.0. I'll just edit my first command and hit enter. So for my routing table, we'll see that we have show IP route static. So these are the two static routes we have there. We have static route pointing to 100.0 network and 101.0 network. The administrative distance is the same, metric is the same, and the exit to the gateway where we're going to is the same. So now let me go to London router and be sure that I've also captured that in my routing table. Show IP route static. Okay, we have only one pointing to the other side. So my London router should be able to read that LAN, that 102 network. I think it's .2. My London router can reach. So if my London router can reach it, somebody under London should be able to reach it. So let me go back to this guy and see if he can reach it. If it doesn't work, then I have to go bring the new routers out. Oh, is it working, guys? Hello? What did we do different? Same thing we did before. We just work our way back. We yank it off. We restarted the router. We put it again. That can give you a lot of money in the feed. I was listening to one guy on YouTube. It's one of the guys I used to follow. He said he has made a lot of money from resets. Resets, restart, reset, restart in IT feed. And that is a major secret for us. Just restarting alone will solve the problem. So what have we done? We can reach that LAN in Germany. Even from Germany too, the Germany guys should be able to talk to anybody because we put them in a routing table. You can talk to 100.2, it's talking. You can reach 101.2 because somebody should have 101.2. You can reach, those are the, so everybody can talk to everyone as long as your router knows how to get to that destination. Somebody under your router, LAN connected to that router can reach that destination. So let me just summarize what I did. We went to Germany router, this Germany router, and told Germany router about this network and this network because Germany router is not directly connected to them. We went to London router and informed London router about this network because London router is not directly connected to this network. So in the long run, this guy has all the three networks. This one, sorry, two networks now. Has all the 5 networks now. 1, 2, 3, sorry, 4. So this one are directly connected. The other 2 that are not directly connected, we inform them. We inform a Germany router manually. When you go to London router, it has 3 that are directly connected. This one. The last one that is not directly connected, we told London about it. So with that, everybody can talk to everybody. So if you see a topology and you have like, let's say 50 networks altogether, LAN and WAN, this is our wide area network now because it's across wide geographical location from London to Germany. LAN and WAN, by the time you calculate, you know that there are 50 networks altogether. Every router must have 50 networks in their routing table. Every single router. Both the combination of directly connected static. Even if you are doing dynamic, every one of them must have 50 networks in their routing table. That is where we say the network has converged, meaning everybody can now talk to everybody. So what we are configuring right now, is called standard static routes. Any question? Thank you, Ahmad. Any question? You are flowing. Let me know. Mr. Yomi, you can ask question. Is Mr. Yomi still in the house? Ali, do you have a question? Okay, do we understand this? Are we cool with this? Yeah, so please talk to me if you're okay with this. Okay, good. Others are not talking. Please let me know if you're flowing. You're okay with this. Definitely. I'm going to send you labs now, Ali. You have to do lab. You know, it is very easy for you to say, yes, right on. We are flowing. We understand. By the time you want to do it yourself, you start cracking your brain. And that's where you cement the knowledge. You don't lab, you can't get this thing done. You can't get it ingrained in your brain. It's not going to work. You will be surprised. You want to teach somebody or explain it to somebody, you'll be cracking your brain. And once you lab it, the moment you lab like this, the first time, second time, third time, you do all these labs again and again, this thing is taking your head. It's okay. Talk to everybody. So sometimes that's not what we want. Can you people hear me? Can you hear me?
Yes, sir.
Okay, good. So sometimes that is not what we want. We don't want everybody to talk to everybody. We just want maybe some people to be able to talk to just one person. Probably that computer is a server. Let me give you a scenario. You have, let's say you have a router here, a router here. This is a link just like what we have here. And then we have a LAN here, and then another LAN here, and then we have a LAN here. So, but on this LAN, we just want people to talk to only one computer. Maybe it's a server that has a software, an application is running. And maybe even on our network, we only want people in LAN A to talk to that server. We don't want people in LAN B to be able to access the server. Maybe LAN A is meant for admin or HR or whatever. LAN B is meant for student and they don't have any business with this server. We can set it up. Sometimes maybe you just want one person in LAN A to talk to just one person in LAN C, or one person that's on the other side. You know, we can set it up. We can say, okay, only one person from this place can talk to this server. And that is what I want to do now. It is static host route, one-to-one. The others will not be able to talk to themselves across. They can talk on directly connected by default. We can filter them if we want. But when we're trying to make people to talk to directly, a remote network, we can say, no, we don't want everybody. We just want one computer to go and talk, or set of computers, or just this network to talk to somebody on the other side for whatever reason. You need to be aware. Let's do that. So I'm going to get rid of our static routes that we did already before. I'm going to get rid of it. Then go to Germany router. We put it there. I think we have to. So no static route here again. Let's check the other side too. No static route. So what if I have a scenario where I only want this computer here to talk to this computer? Only the two of them to talk to themselves. That's all I want. So I'll go to my London router. Tell London router about this computer's IP address. Go to Germany router. Tell Germany router about this computer. Their IP address, not the old network, not the network they belong to. So how do we do that? The other side is 102.2. This one here is 100.2. So I'll go to London router. I'll say, okay, I want to have a communication, one with a computer on the other side. I will still start with my IP route. That computer is 192.168.102.2. Remember the first time we did this, we put the network address. We didn't put host address. But this time around, we are particular about the host, not the whole network, not everybody on the network. So we'll put subnet mask. Watch out. You see that my subnet mask is different. Why did I use 4255? Anytime you are pointing to the host, you are referring to all the IP address, all the octets must be factored in. First octet, second octet, third octet, fourth octet. The first one says when you put subnet mask of 255.255.255.0, you are particular about the first 3 octets that has 255. But in this scenario right now, we are particular about all the octets. So we're going to tell London router, if you have a message for this person with this IP address, 192.168.102.2, we are particular with this subnet mask that is called a host address. Send it to 192.168.103.1. I'm done on London router. I'll go to Germany router. I'll do the reverse for the other IP address. I'll say IP route, IP route 192.168.100.2. What am I saying? I'm telling Germany router, if you get a message for the person with this IP address, same subnet mask of 4255, send it to 192.168.103.2. I'll hit enter. Let's test this. In order for us to test this, let me add one more computer on that Germany router. So you see this thing at work. So let's give this guy .3. So now, let's go to this computer and see if you can ping that .2. We had pinged that .2 before because we specified the whole network. So let's find out if you can ping that .2 again. You're seeing it's pinging that .2. It's pinging that .2. But guess what? The .3 that I just added now is also part of that network, 102 network. Can this computer talk to .3? We are seeing destination host unreachable. Why are we seeing destination host unreachable? Because my router doesn't even know how to get to that network. I mean, that to get that IP address. I only inform the router about that .2. So look at what we put in the router. Show IP route static. We only told the router about this IP address, and the subnet mask is /32, meaning we are particular about all the octets, first, second, third, fourth. And we went to the other side also. We put the address we are particular about. Show IP route static. Look at it here. We are particular about this IP address as a whole. So sometimes in your network, you don't want the whole network to talk to themselves. You don't want everybody to talk to themselves. You can single out the network you want. You can do that. So this is my switch. This is a computer. This is a computer. This is my switch. These are my routers. So I can tell this is London. This is Germany. I can tell Germany router about this computer alone. I can tell London router about this computer alone, if that is what I want. But if I want also, I can say, I want everybody, all the lands here, like we have 2 lands here. I want all the people in LAN A to be able to talk to this machine. But people in LAN B will not be able to talk to this machine. What will I do? I'll go to my router, inform my router about this this computer here. Then what happens on my Germany? I will just tell Germany router about my LAN. So what happens? If anybody pings from here, it will go here. And the Germany router will be able to reply. But if anybody tries to ping from the second LAN, it will not go. Why? Because the Germany router does not know about this LAN here. So with that, I have done network to host. So it's a combination of standard route, standard static routes, and host route. So host route mainly is when you point to a particular computer. And when you point to groups of computer, that one is called summary route, because you can use a particular IP address to group some computers together. Maybe say from .1 to .5 or to .10. Use one particular IP address together to group them together. That is a summary route. Is this clear, please? Host routes. Tell me if it's clear. Same concept, different applications. Same concept, different application. You just need to be on top of the game to know, understand what you need to want to achieve. Are we good? Only Ali and few people are talking to me. Mrs. Bingpe, no, I'm not getting reply from you. Eniola, you've not replied this evening. Are you okay? Are you flowing with this? Mr. Yomi, I say you can talk now. You can ask me a question, please, if you are there. I can't hear anything. The line is cracking.
My network.
Okay, your network is bad. Okay, so let's continue. It's okay.
My network.
It's okay, we can continue. It's okay. It's okay, we can continue. Ali, can you hear me? Yeah, okay, good. It's okay, man.
I'm trying to get the concept as much as okay.
All right, man. So we have talked about standard routes or standard static routes. I have talked about host route, host static route. Now I want to talk about default route. Default route. What is default route used for? It's the easiest of them all. We use default route on our edge router that is connected to the service provider. So let's say now, let me put it this way to you. Let's say my Germany router needs internet connection. So it's connected to a service provider. We can ping directly between them. How will my Germany router get to know about all the networks on the internet? So it means I have to go to my Germany router and start telling my Germany router about yahoo.com, about google.com, about facebook.com, about all the networks on the internet. I don't know all of them. I don't even know, let's say, 1/100. So since I want to be able to reach all the networks on the internet, what will I do? And I need to inform my router, because if my router doesn't know about those networks, it can't reach there. But my service provider knows about all the networks on the internet. So it's either I import all those networks into my router using BGP. BGP is out of the control of CCNA. We're not even advised to use BGP. So what will I do? I'm going to go to my router and tell my router, if you receive message for a network that you are not aware of, you don't know, it's not in your routing table, you don't know what to do with it, just send it to the service provider. And that is what a default route is used for. Let's do it. So I can use my Germany router, I can use my London router. I want to have internet access. So what do? I can bring in another router, connect it to Germany. So I'm going to have another connection on that link, another network address. So let's just imaginary, let's pick 200.100.100.0/30. Most of the time it's always public IP address. So I'll put 0.1 on one end, 0.2 on the other side. So I'll go to this, my router. Now this is for internet connection. Then I'll go to the service provider's router. I don't have access to the service provider in the real world. So what will happen? They will do their own configuration. They will give you the IP details you need for your own end. You are not going to be able to access their own router. They will just tell you what to put on your own router. And sometimes they can tell you to configure your router to pick IP address automatically. That's when you use that command we worked with it to DHCP, IP DHCP on the interface, IP DHCP address or something. So let's call this router host ISP. So this is our ISP router. Let's see if it is reachable from Germany. Ping. You can see that Germany can reach the ISP router directly connected. So what's going to happen? If anybody under Germany want to go out to the internet, anybody here?
Yeah.
Who is that? Oh God. Please mute yourself. Who is that? Ali, can you help me? Bulawan, can you please mute yourself?
Okay.
So if anybody under this Germany router wants to go out to the internet, they have to pass through Germany router. But if the internet, the address, the location you are going to on the internet, if the Germany router doesn't know about it, it's going to get rid of the packet. But we want to tell Germany router, if you receive any message and you don't know where to send it, you don't know where to send it to because you don't know the network, just send it to the service provider. That is one. If we like, we can configure London router so that all the people here also can use Germany router to go to the internet, if we like. But most of the time, what the organization do is different routers with different service providers. London will have its own connection. Germany will have its own connection. Everybody will have their own connection. So I have to go to Germany router now and say, guy, we know that you are connected to the service provider. People will want to go to the internet through you. So how do we configure Germany router to help us to reach the internet? We go to global configuration mode. We say IP routes. Guess what? 0.0.0.0. What does that mean? Any network with any subnet mask you want to go to and you have no idea of how to get there because they are not in your route, it's not in your routing table, send it to 200.100.100.2. This is called a default route. It means a route to any network with any subnet mask. Germany router doesn't know how to go to the destination, but our ISP can get there. So when people want to communicate locally, The German router will check its routing table. It will help them communicate locally because it has everybody within the organization in its routing table. But the moment it see an address that is not in its routing table, it knows that this person is trying to go to the internet. You send it to the ISP. And the ISP has the route to the internet in its routing table, all the locations, and they will be able to go to the internet and come back. That's how people browse. So any router that connects to the service provider must have default route configured. You don't have it, people cannot browse the internet. That is where we use default route. Is it clear? One more, and we're done for the class. We'll now go through the theory and see if there's anything left out. Any question? Oh, doctor, thank you. Doctor said you are good, sir. You're making my head to swallow. Thank you. Are we good with this? Are we flowing? You know, my job is not done until at least 50% of the people in the class understand what I'm teaching. Okay, good. Thank you, guys. Thank you, guys. So when people are not browsing, or you are setting up a network and you need internet connection. I'm not talking GSM router, please. And people are not browsing. You got connection from all these MTN, Airtel, and the rest of them. Check if your router has a default route. If your router doesn't have a default route, people can't go out to the network. That is why routing takes place every time. I was teaching some people yesterday, their new set of students. I started with on CCNA. I say, when you hear routing and switching, that is everything about networking. This is about switch, different technology to implement about switch. That's the backbone of switch. Then when it comes to routing, route, everything about the router. So routing and switching. And that is where we're about to wrap up the class on. We've been doing a lot of switching all this while. We did a little bit of routing, but we didn't point to the routing protocol, the routing concept. But from the last class, we're now pointing to the routing concept, and now we are now implementing this routing protocol. We are now implementing the routing protocol. All right, guys, one more, and we are good. We are good to go. So I will go to the PowerPoint later. Let me just finish my demonstration. Now, the last thing I want to talk about is floating static routes. Floating static route. What is the floating static route used for? You have a router. You have another router. Ideally, we need just one link between the two routers. But we can have two links. We can have two links. Why are we going to have two links? If this link goes down, the other one takes over. Floating static route. People use this also between two different service providers. Let's say this is ISP1. This is ISP2. You want to have a backup connection. You'll be using this one as your primary link. You can be using this one as your secondary link. So you configure your static floating routes. One link goes to this ISP1. The other link goes to the ISP2. Ideally, we're supposed to configure default routes on both routers. But we don't want the two routers to work simultaneously. I mean, two links to work simultaneously, because if I configure default route on this router, now let's say this is our Germany router. If I configure default route and point to ISP1 and configure another default route and point to ISP2, my router will be load balancing. It'll be some will go to ISP1, some will go to ISP2, some ISP1, some ISP2, some ISP1, some ISP2. But that may not be what we want. We may want a situation whereby one is working, the other one is just on standby. How do we achieve that? We configure a floating static route. How do you configure a floating static route? It's just for you to point to. Let me just go to the topology and see, do I have another connection on that? Okay, let's bring in another router. Let me show you this. I don't have port again. Let me yank off one of my ports. Let me get rid of this port. So this is just to demonstrate. So let's go through the other ISP. So let's say this is our ISP1. And let's say this is ISP2. So we configure ISP2. Let's pick 200.100.101.0 for that link. So let's configure this other link. Make sure we have communication between them. Interface, IP address. That is another network entirely. No. 252.0. Overlapping. How can you overlap? Oh, I've used that address somewhere. Okay. I understand now. This should be like dot 5. 5. Subnetting not scatter. I don't want to go through that stress. Let me just pick a different address entirely. Let's say 2.1. Let me just use this one here. No short. So when you have issue with subnetting, this is what the problem you're going to. This is the error message you're going to get on your router. It's going to tell you that you're having overlapping IP addresses are overlapping. So you may have to go and do the calculation again. So let me go to the other side. How about configure the route interface? .201.100.255.0. Okay, so let me be sure I can ping between the two routers. Ping. Good. So now on Germany router, I already have a static route. Show IP route static. I mean default route. See my default route here. And look at the sign for default route. I didn't even show you that. Show IP route. S and asterisk. That is a default route. Regular X is standard route or host static route. So now you see we're pointing to this service provider. We also want to have another static route because we have two legs to two different service providers. So I'll go to my global configuration mode and say IP route again. 0.0.0.0, 0.0.0.0. This time around, I'm pointing to my second service provider, the secondary one, which is 201.100.100.2. Guess what? If I hit enter, see what is going to happen. See what's going to happen. Do show IP route static. Look at what is going to happen. My router will be load balancing. Some people will be going through ISP1. Some people will go through ISP2. Some people going through ISP1. Some people go through ISP2. It's going to load balance between the two service providers. But that's not what I want to achieve. I want the second service provider to be on standby. So what will I do? Same command that I put there. Look at the administrative distance here. By default is 1. I can just increase my administrative distance to 2. Don't forget what we discussed on administrative distance. Lower, the better. If I hit enter right now, that route will be removed from the routing table and will be dropped as the backup route. If the first one goes down, service provider 1 goes down, the second service provider will pick up automatically. So if I do that and issue that command again now, you see that network has disappeared. The second route has disappeared. The second route has disappeared. So it is only service provider 1 that will be available in my routing table. So what happens when service provider 1 goes down? 2 picks up automatically. Let's shut down the interface of service provider 1. Let's see if 2 will come up. What's that interface? G0/2. Let's shut it down. That is to simulate that that network is down. 0/2. Shut. Then issue that command again. What did you see? The second service provider has picked up 201.100.100.2. That is my ISPB. He has picked up. When that interface comes back, what happens? When that interface comes back, what happens? 200 has taken over again. The second service provider has gone on standby. That is how we use this floating static route. We want the other link to be floating, the other connection to be floating. It's not going to be active at this point in time. And that is where we use this particular one. Is it clear? Did that make sense to you guys? Please, can you mute yourself? Who is that again? Yeah, Ali, thanks. Anela, thank you. Dr. Samuel, are you there? Okay, good. Good. So a lot to learn about default route. A lot applications, how you make use of default route. So floating static routes. It can be floating static default route, and it can be regular standard route. We can make regular standard route to float. So this is for service provider. I can use it between my two routers too. So okay, you can pass through this link 1. You can pass through this link 2. It makes no difference. But anytime you have a route that is floating or is on standby, a network you've defined that is on standby, that is the backup connection for you to use. So this is people use this a lot to have a backup service provider, because probably they don't have the same speed for the two service provider. They just want to be on standby permanently, and that will be all. So let's walk through the remaining part of the PowerPoint and see what we got there. Okay, so we've done a lot of demonstration. Let's see how we can quickly wrap this up. Okay, any question for now? It's the same concept with IPv6. So when I can't bring the two together here in the class. I won't finish this class in 3 hours. So I need to design or add IPv6 address. This is the same concept. Just that anytime you want to configure for IPv6, you say IPv6 routes. Where is it? Okay, I'm coming there. Let me just talk about this part now, and then we'll continue. Okay, I believe there's no question. When configuring a static route, the next hop can be identified by an IP address. You see, that's what we've been doing. Or exit interface, or both. What do they mean by that? I can also create my static route and say IP route 0.0.0.0.0.0.0.0.0. Instead of putting the IP address of the router, the next router, I can put the interface that is taking me out. G0/0, G0/0, whatever be the case. And I can combine the two, but this is not recommended. So next up route, that's the next up IP address. Directly connected static route, only when you put the exit interface. And when they say fully specified static route, when you combine the two, the IP address and the exit interface, that's what they pay. You specify the route is fully specified. It's fully specified static route. But what we use most of the time is the next up. That is what we use most of the time. So let's go to the configuration and what they put here. We have done all of this. They have their own topology, IP route pointing to the remote networks. We did it now. Okay. If you want to do for IPv6, it's just the only difference is to say IPv6 route, then the remote network, then the slash, then you point to the next up IP address. That's the difference. But whenever you are doing with IPv6, don't forget your IPv6 unicast route. Don't forget that. Okay, so I really don't like their own topology. So commands, show IP route static, show IP route, you can define the network, This command, I think I really like it, but I have not mastered this. It's not, it's just in my head brain. Show running config, pipe, section, IP route. Just fetch out all the configuration you have done as far that has to do with static route. What about your default static route? We've done that also. That must be done on any router that is connected to the internet. It's also referred to as a stub router because it needs to know about all the networks on the internet. And look at the configuration, IP routes, the network, subnet mask, the IP address, or the exit interface. And the same thing for IPv6. This, I forgot to mention this. For IPv6, you say : /0. That is how we configure default route in IPv6. IPv6 route : /0. That's how we configure IPv6 in the IPv6 default route. So you can see an example of default route here for IPv4. You can see the one for IPv6A. How do you verify the static route? Show IP route static. It will just show you the static route that's been configured. And when you see static, it's just the regular standard static route. But when you see asterisk with it, where is that asterisk here? See it here. It's also called candidate default route. That means it's a default route. Any network with any subnet mask. What about the floating static route? I've just explained it. You tweak the administrative distance so that you can have the other one in the routing table. Look at a scenario. I've given one scenario and I tested it for you. You can see one service order goes down, the other one picks up. So you can have it in a different scenario here. Like look at this one on router 1. You can pass through this link and then you can pass through this link to go where? No, let's from the other side. This router 2 can, what are they trying, how are they trying to explain their own name? If router 2 fails, just a minute, guys. I don't think I understand this their own topology. This their own example here. But I'll give you a good one, Sha. I'll give you a good example for testing a floating static route. Let me see. They don't have. Let me see. We don't have a backup route here. Because if this router goes down, this link is also down. This link is down. I need to look at this again. So, but I'll give you my own example. Static host route, I've also told you how to do that one. That's when you install, because you want to just reach a particular computer, just a host. Look at this. Sometimes, most of the time, you use this for a server. When you just want people to reach a server and you're good to go. Look at the configuration. You specify the IP address with 4 255s. 4 255s. And when it is under IPv6, you use /128 for static host routes. That is it. Any question?